Okay, so if we have to, oh, no, I want that. If we have to use an arithmetic sequence to solve a problem, this is, I think, the form that um, Newton uses, and you can see it in a couple of slightly different variations. They all mean the same thing, though. So I think it's helpful to write out the first few terms of the sequence you're talking about. Manufacturing company produces 250 units per day currently. So I'd say that's the first term of our sequence, okay? So this is, then the company's goal is to increase the number of units manufactured per day by 50 each year. So this is year 0, kind of. We haven't gone anywhere in time. So I guess maybe we could call that A0, but it starts getting confusing if you start indexing something other than 1. If we're increasing by 50 each year, then at year 1, 1 year away, we should be at 300. And then year 2, if you want to have another term, then we should be at 350. And then you could actually just keep counting using this column to find out how many units we're going to be producing 4 years from now. But there's lots of word problems where you're going to have to use the equation to predict because it's just too impractical to try to count. So let's come up with this equation here. To find out the nth, how much is being produced at the nth term of the sequence, then we have our starting term of 250 plus, now this n minus 1 has to stay because that's just part of the formula that's built in. We need to multiply by the common difference of 50. Okay, it would be negative 50 if we were decreasing 50 units each year. It's positive 50 because we're increasing 50 units each year. This is the sequence that tells us. But remember, n stands for something a little slightly different. If n equals 1 with this formula, then we're at year 0. So n equals 5 would be year 4. So we got to plug in 5 in for n. So we got 450. And you would get that by doing this counting. Year 2, we're at 350. Year 3, we're at 400. Year 4, we're at 450. Let me see what other trouble we can stir up here. Oops, I'll keep that Newton's form. Timothy has deposited 140 into a savings account for each month this year. Plans on depositing 35 more per month for the savings account each year. So same type of thing for this problem. Okay. Let's try doing it with a sub 0 this time. After no time, has passed, meaning this current moment, Timothy's got 140. Okay, so we can modify this formula a little bit more. A sub n, meaning the amount that we have after the nth year, is the starting amount of 140 plus n minus 1. No, I think we're still going to be stuck here. Oops, come on. I got another idea. So after no time, at year 0, we've got 140. At year 1, we've got 175, right? And at year 2, it keeps going up by 35 each year, so we got 210 at year 2, and et cetera, et cetera. You can keep doing this until you get to 7, but just to do it the proper math way, we should probably complete the whole equation. So the nth year is found by taking that a sub 1, 175, plus n minus 1. This way we don't have to worry about the interpretation of n. N makes sense. N is the number of years. So times the common difference of d, which is 35. So if you want to know the 7th year, you just plug in 7 in for n. Okay, so 35 times 6 plus 175, we get 385. So we're expecting to have $385. You could have got that through just adding 35 each year too. But anything else? Oh, this is different. Let me do this one for you. How many terms are there in the following finite arithmetic sequence? I think I've heard it pronounced both ways. But how many terms is a good question. So I think we can get this just by coming up with the equation. Okay, a sub n equals a sub 1, which is 30, plus n minus 1 times the common difference. They're all increasing by 8, so that's our common difference. So we want to know what n is. when we've reached 150. Okay, the reason is because this is the last term in the sequence. If we can find out if we can find out what this stands for, like this is n equals 1. Oops, this is n equals 1. This is n equals 2. This is n equals 3. If we can find out what n equals for 150, then we've found out how many terms are in the sequence. So plug 150 in for a sub n. And now you have an equation to solve for n. 30 plus. I can't believe I did that. I'm sorry. 30. Distribute this 8 to everything on the inside, so plus 8n minus 8. Now, I think you could probably take the equation from here. 150 minus that 30 plus that 8, divide by 8. Doesn't come out to an integer, we're in trouble. So we just found out there are 16 terms in the sequence. This is n equals 16 when you get to 150.